What if you could teach an AI not just from a textbook, but by actually letting it learn on the job? Well, today we're diving into a breakthrough method that does exactly that. It's called Agent Reinforcement Fine-Tuning, or Agent RFT for short. And believe me, it is completely changing the game for how we build powerful AI. Okay, so first things first, what are we even talking about when we say AI agent? The key thing to understand is that an agent isn't just a chatbot. It doesn't just talk, it does things. It has access to tools, a terminal, a code interpreter, a whole code base, and it uses reasoning to combine those tools and get complex tasks done all by itself. And that brings us to the million-dollar question for anyone building an agent right now. How do we make them better? How do we make them more accurate, more reliable? Well, typically developers have a pretty standard playbook for this. Think of it like a ladder. You start at the bottom with prompt engineering, just tweaking your instructions to get the model to do what you want. If that's not enough, you climb up to task optimization, where you might simplify the problem or give the agent better tools. And when you've squeezed every last drop of performance out of those methods, you get to the top rung, fine-tuning, where you're actually changing the model's internal weights. But what if you've done all that? You've climbed the whole ladder, and you've hit a ceiling. What if you need a truly massive leap in performance to tackle the problem you're trying to solve? This is where Agent RFT comes in. And it is a totally different way of thinking. Instead of just studying, the agent gets to go out and explore, to experiment in a live environment. And, this is the crucial part, it learns based on rewards we design. It gets a point for a right answer, maybe loses a point for a mistake. It's learning what good actually looks like for your specific task. The best analogy for this is the difference between reading a textbook and actually doing an internship. Traditional fine-tuning is that textbook. It's static, it's predictable. Agent RFT is the internship. It's messy, it's real world, it's learning by doing. And this is a huge deal, by the way. This is the first time OpenAI has let models interact with the outside world during the training process itself. So what is this really for? Well, as the team at OpenAI puts it, it's for models that have to, and I quote, call tools and interact with the outside world in a multi-step fashion. So let's be clear. This isn't for your simple chatbot. This is for the heavy-duty, complex agents that are tackling big, real-world problems. So why is this such a game changer? Well, for one, it adapts the model to your unique environment, which helps it get over that gap between generic training data and your specific problems. By learning on the job, it just gets way better at using your tools, which makes it faster and more efficient. And the craziest part? You don't need a mountain of data to do it. Some teams are seeing incredible results with as few as 10 examples. 10! Okay, the theory sounds fantastic, but does it actually work? Let's take a look at what happens when the rubber meets the road. We're going to check out 4 amazing real-world breakthroughs from companies that are using Agent RFT right now. First up, Cognition. You've probably heard of them. They're the creators of Devin, the famous AI software engineer. They used Agent RFT to improve the part of Devin that inspects a codebase and figures out exactly which files it needs to edit. And what they found was, wow, just look at this. They discovered a direct, almost linear link between high-quality data and performance. With about 100 examples, they saw a solid 5-point boost. But when they ramped that up to 1,000 examples, the improvement doubled to 10 points. So there are 2 massive takeaways here. First, obviously, data quality and volume are king. But the second lesson is just incredible. RFT didn't just teach the agent to be more accurate. It taught it to be way more efficient. It learned how to use its tools in parallel, basically cutting a clunky 10-step process down to just 4 super efficient steps. That is a gigantic speed up. All right, next up, let's look at Codo. They're building a code review agent, and they used RFT to beef up its ability to do deep research and answer developer questions about really large code bases. This visual just says it all, doesn't it? Before RFT, the agent would sometimes go on these wild goose chases, these bad runs with more than 15 tool calls. It was unpredictable. But after RFT, look at that. Those messy, inefficient runs completely vanished. Its behavior became stable, predictable, centering on just 2 to 4 tool calls. It didn't just get smarter, it became reliable. Our third case study comes from Cosine. They built an agent to work on huge, complex enterprise code bases. And to do this, they trained it on a massive set of 30 different tools, everything from simple keyword searches to entire browser sessions. So what was their secret? It all came down to a really, really clever reward system. First, it was strict. The agent only got a reward if its final code passed all the tests, no partial credit. Second, they actually rewarded the agent for self-validation, for running its own tests and double-checking its work before saying it was done, just like a good human developer would. And for our final example, we've got Mako, and they're doing something that is traditionally incredibly difficult for AI, writing high-performance code for GPUs. And the result they got was, well, it's just astonishing. Their agent beat the state-of-the-art performance by 72%. 72. And they did this with only about 100 training prompts, using a smart little trick of running 3 attempts for each prompt and just picking the best one. Now, it wasn't all smooth sailing. They ran smack into a classic problem called reward hacking. This is when the model finds a lazy shortcut to get the reward without actually doing the work, kind of like a kid who cleans their room by shoving all the toys under the bed. Mako figured out 7 different ways the model was trying to cheat, so they built a whole separate judge AI whose only job was to catch and penalize that bad behavior. So we've seen some absolutely mind-blowing results. Now, let's try to distill all of these lessons down into a few golden rules for making your own agent training a huge success. So let's boil it all down. First, you have to define success clearly. Second, just like Cognition showed us, your training data has to look like your real-world problems. Third, your environment has to be set up so that the agent can actually explore and find better ways of doing things. And finally, as we learned the hard way from Mako, you have to build a reward system that is basically unhackable. And all of this brings us to one final, really provocative thought. Agent RFT gives these models a way to learn not just from books and data, but from direct, hands-on experience in the world. So the question we're all left with is this. If an AI can learn to do practically any task just by doing it, what on earth will it learn to do next?